So we left off yesterday. We were talking about converting percents, decimals to fractions to percents, and back and forth. And then we looked at those benchmarks. And just a quick review of those benchmarks. If I have like 4,200 as my number, and I want to find 10% of it. Remember, 10% is 10 out of 100, or 1/10. To get 1/10, I'm just dividing by 10, so it moves the decimal point over one spot. So 10% of 4,200 is 420. 1%. Remember, 1% means 1 out of 100, or 1/100th. So 1/100th of that, I'm dividing by 100, or moving the decimal over 2 spots. So that's 42. And I can use that to create, as we mentioned yesterday, some simple percents. So let's say if I want to find 12% of 4,200. 12% can be thought of as 10% plus 1% plus 1%. So 420 plus 42 plus 42 adds up to 504. That's 12% of 4,200. Or you might ask for 19% of 4,200. We can think of that as 10% plus 10% minus 1%. 10%, of course, is 420. Another 10%, bless you, is 420. 1% is 42, so we're subtracting the 42, which ends up being 798. So you can use these benchmarks to calculate percents fairly quickly. And at the very least, you can use them to estimate percents. So to do some exact calculations with our percents, we look back at what we did to convert a fraction into a percent. When I had a fraction like 7/8 and I want to convert it into a percent, I treat that as 7 out of 8, and a percent is always out of 100. And we treated this like we did any other proportion. We cross-multiplied. The two numbers that are diagonal from each other are the 7 and the 100, so we multiply those. That's 700. Then we divide by the number that's alone on the other diagonal, which would be the 8. So that ends up being 87.5. So it's 87.5 over 100, or 87.5%. This proportion is the key to doing all of our percent calculations. So if I want to find %35 of 80, I'm going to start with the percent. In fact, anytime I'm working with a percent problem, I try to start with the percent. 35% is 35 out of 100. Now I want to talk briefly about what each of these pieces mean. The 100 down here, first of all, represents the whole thing, or the starting amount. It is the number that is the basis of our calculation. It is often one of the terms that's sometimes used for it, and I think our textbook uses it too, is the base of the percent. What that means is that is the number that is used to calculate what the percentage is. The 35 is a portion or piece of interest. It is part of whatever is represented by the 100. It's part of the whole thing, but it's got a special property that we're focusing in on. So now on the other side of this percent problem, we've got to match up numbers with the 35 and the 100. So in this problem, there's always two other numbers. Usually one of them is missing. So in this case, we've got the 80. Then we've got the number that we're being asked to find. That's the number that's missing. Well, there's two things to interpret here. Two clues that tell us where to put those. First of all, it's saying find the 35%. So that's implying it's telling us to find the number that matches up with the 35. The 80 here, it's of 80. We can think of that as saying out of 80. Out of 80 implies that the 80 goes on bottom. So now then, to find that missing number, we will cross multiply and divide. 35 times 80 is 2,800, divided by 100 is 28. So 28 is 35% of 80. Now there are a lot of different ways to word these problems that mean pretty much the same thing. So we have blank is 120% of 35. So I have the 120%. So I'm going to start out with a percent. 120% is what? 120 out of 100. Now on the other side of it, we have the missing number, we have the blank, and we have the 35. Which one of them matches up with the 120? Well, it says blank is 120. So that blank, or that missing number, matches up with the 120. Of 35, again, we can read that as out of 35. It implies the 35 goes on bottom. When we say 120% of 35, that's telling us that 35 is the number we're basing our calculation on. So now we cross multiply. 120 times 35 is 4,200. Divided by 100 is 42. So 42 is 120% of 35. Now we look at that, it looks awkward because we got a number that was bigger than the 35. Why did it turn out to be bigger? It's 120%. It's more than 100%. 100% is the whole thing. It's 1. So if it's bigger than 100%, we're going to get back something bigger than what we started with, bigger than the whole thing. Yet another different way of wording it. As always, I'm going to start with my percent. 80% is 80 over 100. Now, of 70, if I read that again as out of 70, it implies the 70 goes on bottom. Then if I cover up that of 70, I get 80% is blank. It implies that missing number matches up with the 80. And I cross multiply and divide. 80 times 70 is 5,600. Divided by 100 is 56. So 80% of 70 is 56. All three of those problems, even though they looked different, were the exact same type of problem. We were looking for that piece that matched up with the percent. But we can have different types of problems. You know, we can have 32 is 40% of blank. So now again, I start with the percent. I have 40%, that is 40 out of 100. Now on the other side, 32 is 40%. That implies the 32 matches up with the 40. Again, the out of blank, if I think of that as, or the of blank, if I think of that as out of blank, it implies that missing number goes on bottom. And now I can cross multiply and divide. 100 times 32 is 3,200. Divided by 40 is 80. So 32 is 40% of 80. 70% of blank is 35. So again, I'm going to start with my percent. 70%, 70 out of 100. On the other side here, we have the missing number and we have the 35. Does the 35 go on top or bottom? It goes on top. So you think this 70% is 35. The of blank, again, we read that as out of blank, implies that missing number goes on bottom. We cross multiply and divide. 100 times 35 is 3,500. Divided by 70 is 50. So 70% of 50 is 35. Now you'll notice when I went from these problems to these problems, the numbers were in different spots of the proportion. The missing number was in a different spot. And we still cross-multiplied and divided. Even though we cross-multiplied in a different direction because of where the numbers were, the process to solve it is still cross-multiply and divide. And that's what I like about this proportion method is it's always cross-multiply and divide to find your answer. If we keep going with these, we might have 24 is blank percent of 80. Now, I've been telling you to always start with the percent. Unfortunately, here the percent is missing. But I'm still going to start with it. Blank percent is blank out of 100. On the other side, we've got the 24 and the 80. Which one of them is going to go on top? 24. 24 is blank percent. That implies that 24 goes with that blank. Of 80, again, you can think of that as out of 80. It implies the 80 goes on bottom. So once again, the numbers are in different positions here, but it's still cross multiply and divide. 100 times 24 is 2,400. Divided by 80 is 30. So that's 30 out of 100, or 30%. 24 is 30% of 80. Or you might have blank percent of 30 is 27. Again, we're missing the percent, so we start out with blank out of 100. On the other side, we've got the 30 and the 27. Which one goes on top? 27. I should have said is 27, not in 27. Yes, the 27 goes on top. Again, the of 30, you can think of that as out of 30, implies the 30 has to go on bottom. So 100 times 27 is 2,700. Divided by 30 is 90. So that's 90 out of 100, or 90%. 90% of 30 is 27. So like I said, when I use that proportion, the math is always cross multiply and divide. All we have to do is get things in the correct position within that proportion, and the calculation is easy. Some of you may have been taught what's called the rate method of percents. This is the way I was taught, and this is the way I do a lot of my percent calculations in my head. For the rate method of percents, you take the percent itself, the 35%, and you turn it into a rate. A rate is the decimal form of the percent. So 35% is 0.35. And then what you do is you take the 80 here, and you would multiply by the 0.35, which gives us 28, which is the answer to that problem. Same with this one. 120% is going to become 1.2 as a decimal. So then you take the 35 times 1.2, which is 42, which is the answer to that problem again. And even this one, 80% becomes 0.8. So you're going to take the 70 times 0.8 gives us 56. Well, that looks really simple, so why don't we do it that way? Well, because we run into problems like this next one here, it's a little bit different. 40% is 0.4 as a decimal. But to solve that one, I'm not going to take the 32 times 0.4, because what I'm missing is the whole thing. I'm going to do 32 divided by 0.4, which gives me 80. So if we're going to do that rate method, we have to know, we have to be able to figure out at least whether we multiply by that rate or divide by that rate. Like this next one here, 70% is 0.7. That one would be solved by taking the 35 divided by the 0.7. Gives us the answer of 50. And then there's a third type yet, which is this next type, where we don't have the percent. To do those, you take the portion divided by the whole thing. 24 divided by 80 is 0.3. And then you move the decimal point to make that 30%. So if you're going to do that rate method, you have to be able to pick out what type of problem it is and decide, do I multiply by that decimal? Do I divide by that decimal? Or am I dividing out numbers and converting it to a percent later? So the rate method I found causes a lot more mistakes. Now there are some there are a lot of applications out there where we are going to be starting with that large number, that whole item, and trying to find a piece of it that's based on the percent. And in that case, the rate method would be easier to use. For example, if you're looking at a sales commission, if your sales commission is 8% of sales, and you have sales of, let's say, $7,000 for that period, your commission is always going to be finding that 8% piece out of that 7,000 whole amount. So there it would be easier, just do 7,000 times 0.08, get $560. So there are going to be applications like that, like commissions and interest and stuff, where using the rate method is preferable, it is easier. But it's always if we're going from that whole amount and then trying to find that piece that we're focusing on, that piece of interest. So for the most part, the proportion is going to be easier for us. And that proportion even gets easier for us when we throw in word problems. For example, let's say that we know that 2% of parts are defective. How many defective parts do we expect on a day when 56,000 parts are produced? So on a word problem like this, I start out with the percent. The 2% is 2 over 100, and I label it. The 2% is focusing on defective parts. Now remember we said the 100 is usually the whole amount, or the whole item that piece is taken out of. Well, that 2% of defective parts is taken out of the group that is all parts. So that 100%, the 100 represents all parts. So on the other side of this proportion, we have the 56,000. Does that represent the defectives or all the parts produced for the day? All the parts produced. So that has to go on bottom. So this proportion, if we make sure we label what each of the numbers means, it helps us set it up, because we know since 56,000 also represents all the parts, it has to go on bottom with the 100. because those are the two numbers that represent all the parts. So then to find the number of defectives, or the expected number of defectives, we cross multiply and divide. So we're expecting 1,120 defective parts. The opposite side of that is, again, we know that 2% of parts are defective. How many parts were produced on a day where there were 1,060 defective parts? So we still have that 2%. So it's going to be 2 over 100. And again, just like before, the 2 represents the defectives. And the 100 represents all parts. So on the other side of our proportion, does the 1,060 represent defectives or all parts? Defectives. So that has to go on top. And now we cross multiply and divide. 100 times 1,060 divided by 2 is going to give us 53,000 parts produced. Does that make sense? You don't look like you're sure back there. Not today? Just the word problems themselves, or the percent calculations before the word problems were okay? Okay. It does take a while to get used to the word problems. So let's try something like NPD Corporation estimates weekly profit as 12% of gross sales. Find the gross sales for a week when profit was estimated at $40,920. So, what percent do we have in the problem? 12%. That's 12 out of 100. The 12% represents what? Profit. Weekly profit as 12%. That profit is calculated as a portion or a piece of what larger number? Gross sales. So the 100 represents the gross sales. That's the whole thing, or the larger number that the profit is calculated as a piece of. So then over here, the 40,920, does that represent profit or gross sales? That's the profit estimate. Without labeling it, a lot of people would put that 40,920 on the bottom just because it's a big number and it's a reflex. So we cross multiply and divide. 100. 341. Okay, perfect. 341,000. So yeah, gross sales were $341,000. What do you think? Maybe? We do have to be careful with our percent problems. So after a 20% discount, you pay gotta be careful here. $27.20 for an item. How much did you save? So we've got the 20%. It's 20 out of 100. The 20 represents what? The discount. The 100 represents what? It represents the full price. So the discount is always going to come from the full price, or what it was before the discount, right? We look at the 27.20 here. Is that the amount of the discount? No. That's how much you paid after. It's not the full price either. That doesn't represent either one of those. There you go. That's exactly it. When we're dealing with percents, there's always hidden percents. In this case, 20% comes out of the full amount, which means that there is another lurking percent. 100 minus 20 would be 80%. 80 out of 100. The 100 still represents the full price. The 80% represents the price after discount. In other words, that's the amount you paid. So on the other side over here, that $27.20 is the amount you paid. Come on. So we cross multiply and divide. 80 times 27.20 divided, 100 times 27.20 divided by 80 is what? 34 should be. $34. Is that what we're looking for? We're looking for how much you saved. The 34 represents the full price. So to find the amount saved, we still need to subtract. Comes out to $6.80 is the amount saved. So by labeling these percents in our word problems, it helps us to avoid making a lot of mistakes. Again, here, a lot of people would throw in the 27.20 right here. Well, it's not. That's not the full price. That's the price after the discount. And even down here, once you get it put in there right, a lot of people would cross multiply and divide, get the 34 and say, oh, there's my answer. Well, no, 34 is the full price. We still have to subtract to find the amount of the discount, how much we saved. Now, a simpler version of that problem would look like this. After a 30% discount, you saved $8.10. Very good question. Well, let's start out with the 30%, the 30 over 100. The 30 represents the amount of the discount. And of course, the 100 is full price. And what you actually label them doesn't matter. What words you use doesn't matter as long as you know what they mean and what they're representing. You might use, savings instead of discount, or before discount instead of full price. Whatever you label them as long as you understand what they mean. Now on the other side here we have the $8.10. Does that represent either one of those amounts? You saved $8.10. That is the discount. So we're going to cross multiply and divide. 100 times 810 divided by 30 is going to be $27. But now that 27 represents the full price. Is that what we want? No, we want how much you paid. So it's 27 minus the $8.10, or $18.90. So labeling it out here, yeah, the 70% is what we were looking for, but we didn't know the whole amount. We didn't know what represented the 100. So we still had to use the 30% to find that whole amount so that we could still get to that discount. So you've got to be very careful with these. Like I said, I label them out. In fact, I will sometimes, and we'll talk about this more on Monday, I actually, when I come to discounts and markups and taxes and stuff, I use a little table like this. Where I might start out with full price minus the discount equals the amount paid. And when you're dealing with a percent problem, every item is always represented by two numbers. They're represented by percents and then some other number. In this case, it might be dollars over here. So here we had that dollar amount of $8.10. That represented the discount. We had the 30%, which also represented the discount. Full price, the starting amount is always 100%. So we could find the amount paid. What's 100 minus 30? 70%. What we were looking for here is the amount paid. So what I can do is I can ignore this top row. And instead of comparing one of my percents to 100, I'm actually comparing in this problem 30% to 70%. And I can actually cross multiply and divide right within this table. 70 times 810 divided by 30. Or 70 times 8.10, so divided by 30, is, oops, what went wrong there? Is that right? $18.90, yeah, that is what we paid. That is right. $18.90 is what we paid. So these percents are very versatile. You just have to keep track of what you're finding. I'm getting into the stuff we're going to cover on Monday, so I'll stop there for you for the day. On Monday, we will go over the percents. This is a percent decrease problem here, where the number is getting smaller by a percent. We'll also look at percent increase problems, which is like taxes, adding sales taxes, or markups and stuff like that. We're also going to look at interest. Monday is one where I talk a lot about investment and stuff like that. For now, there is that quiz that is due today by 11:59 p.m. And there is that homework from yesterday that is due Monday. The test? Yeah, it looks like I'm going to wait till Thursday. We'll put the test on Thursday. One of the main reasons I was thinking about moving it up till Wednesday is because we don't have a lot of material for Monday, but I can stretch the investments. There's a lot of stuff about investments that everybody should know that I can stretch in there to fill up the whole 2 hours. Then Wednesday will just be a review for the test on Thursday. So we've got about 12 to 13 minutes left. If you guys want to use the computer lab next door to work on the homework or the quiz, please feel free. Otherwise, we'll see you on Monday.